Okay, now I'm going to show you the finished product. Basically, I have it to where I've rigged a wire that attaches to this rocker switch. When the rocker switch is in the remote position, the 0, you can activate that with this remote switch. And so that's the way it works. You can use a switch, or you can use something like this, an electronic switch or a relay, to do the same thing. And I'm going to explore that in another video. I'll go into configuring a relay to activate this. It turns out that this is 12 volts. It's a 12 volt signal, and it's fairly low amperage, but we need to protect, since it does have 12 volts, we do need to protect this wire because we're going to be running it all over the boat, and we may have issues with shorting it onto something. So the other thing is I just put these Wago connectors on it, but that's and then just labeling. Of course, if you wanted to, you could still operate it just by turning this switch on, and that actually overrides the remote capability of it. So I'll show you a little bit more how I went about configure the installation. The purpose of this video is to show you my project on where I added a remote switch to a Xantrex Xpower 1500 that I'd been using on my boat for some time. Some of those inverters have an auxiliary already on them. However, mine did not. So I'll discuss how I went about determining, what voltage and what amperage the switch had, and some of my thought process on how to do this as safe as we can. Of course, I'm not a marine electrician, and fooling around with inverters, you sleep on your boat at night, and you're going to open up a cover of an inverter and mess around with it. Probably you got to be careful, right? Probably not the smartest thing to do, maybe, but I think it's going to work out for me. We sleep on our boats and everything, so maybe turn the inverter off when you're sleeping, possibly, and that'll mitigate some of the risks. So stay tuned. I'm going to show you the disassembly process. I'm going to show you roughly how this may integrate with a remote switch or a relay, and just the total installation of my thought process. Thanks a lot, and stay tuned. Now I'm looking at bypassing the switch on this Xantrex Xpower 1500 watt supply I've been using for a while on my boat. And so what I've got is a bench power supply I'm looking at here. Sorry for the shake on the camera, it's my phone. So I'm connected to this the inverter now, and I've got it opened up, and you can kind of see that there's a switch in there with 2 leads on it, and it's pretty thin wire. So don't want to touch it, but the switch is right there. And so what I've found is the voltage on that switch is let's see if I get a light on it here. So the voltage on the switch is I'm reading like about 13.8 DC on this switch. Now the switch is an AC switch, but let's see if I can get a better light on it there for you. But so it's just got two solder terminals. You can see that the wire is not very thick, which kind of probably makes me happy. That so we're gonna actually read how much current is going on this switch just for the heck of it. Right now for the load, I've got a soldering iron right there, and you can kind of see the strobe on it. And so I've got roughly 2.11 amps running into the inverter with and you can see that over here I'm using I got my mic messed up, so I'm using a constant current, constant voltage power supply set up right now into constant voltage mode, and it's saying I'm drawing 2 amps. So I think that's right. So let's see what the amps are. We're going to see what the amps are out of this on over here, and that'll be my next test. So for this next test, I'm basically putting a clamp on each leg on each tab of this micro switch, rocker switch. And so the rocker switch is in the off position now, and so you can see the inverter is off. Okay, so what I'm gonna do is and I've turned off the soldering iron, so there's no load here. This is the only thing that's going to be loading. And so what I want to attempt to do is jumper that switch, put the switch on without flipping it, right? So what we're going to do is hook this lead and then this lead into common. Okay, so when I did that, what's happening is the amps are going through. I've got like I got about 40 milliamps right now running through this meter. So the meter is now in between these two legs of the switch, and you can see now the switch is off, but the meter is acting as a sort of a switch, always on switch right now. So the question is, what's the voltage? And I'll answer that one. The voltage the voltage on this switch right here, on the voltage leads is 13.8, which matches my power supply. And you can see right there that the amps, it's 0.2 amps right there on my my power supply is reading 0.2 amps, right? But I'm reading quite a bit less here on this meter here. I'm reading quite a bit less. I'm reading 40 milliamps of draw on the switch, okay? So the question is, when I turn the soldering iron on, which is a big draw, is the amps on the switch that I'm running over the switch, is that going to change? If it is, if it does change materially, then we have to make sure that we have a better relay. But let's see what happens. So I'm going to go to the switch here, the soldering iron, and you can see that came up, and it's okay. So we basically have only 55 milliamps of load, and you can kind of see what happened there. We went up to 3.0 amps, so we really boosted up the amps, but we're just dealing still with milliamps there, 53 milliamps. So we're really not we're really not running much current through these wires here. So we don't need very big relay to be able to do the job that the switch is doing. Now, just for the heck of it, I'm going to go turn this soldering iron off now, and we're down to about 40 milliamps. So we're really not picking up much current draw with this switch with the soldering iron load. So here's you can see where I soldered the top leg there, and the bottom leg there with red and black wire. Red and black doesn't mean anything. Of course, we have this is going to be around 12 volts DC, and this one is just going to make the other connection. So I'm using 18 gauge marine wire, and I just used that soldering iron. I got my light on, sorry. And I like marine wire because it's pretty flexible, and I just got this stuff on I think I bought it at West Marine, a whole reel of it. And so then I think, because we're on a boat, or if you guys are in RVs, we're probably going to want to sorry, my light went away here. So we're going to want to strain relief this with a tie wrap, I think, and leave loops. So we'll strain relief both ends, and so then we're going to have a situation where we're going to be able to bypass this switch. So on eBay, they give you a really good deal on this these marine grade, they're Crimpaseal, and I recommend using marine, if you can, use again marine grade wire, and then these are adhesive lined shrink tubing. That is, it's very I think important to get watertight. So all inverters are not created equally with respect to these remote switches. Some of them are very simple, and some of them end up, the latest ones have actually a circuit board in here, a 4-pin connector, and then you're going to press this, and that activates a microprocessor based latch in this inverter. And so I think that when you see if a remote switch like this, you should be happy maybe with the switch the way it is, but if you're going to try to integrate that for a BMS or something like that, you're probably going to have a hard time, because there is a circuit board in here. It operates a latch. It's very complicated. So, well, the Xantrex that I'm using is it's a very simple rocker switch that probably is roughly the same situation as some of the older inverters, and you can probably pretty successfully just use my same recipe from the Xantrex inverter to another inverter charger possibly, but I think you should always measure the voltage, measure what's happening inside like I show you on the video.